All right, here's a thing about the derivative function. To review with you, after you find that first derivative, you can set that first derivative function equal to 0 and solve for x to find those critical points. These critical points are going to be where maximum and minimums can occur, or the max and min can occur at the end points. So here's an example below. We have a curve on that function, and there's a maximum value of y that occurs at the end point x equals b. So here is that maximum point. There is a minimum point of y that occurs at the local minimum, which is right here. So optimization is our next concept that we're going to learn. Optimization is the process of finding the maximum or minimum value of a function. So optimization is finding the maximum or minimum value of a function. The solution is often referred to as the optimal solution. We can find these optimal solutions in several ways. One way is to use a graphing calculator and to search for that max or min. Another way, which we learned in Algebra 2, is to use the formula x equals negative b over 2a, which will help you to find the vertex of the parabola. Another way is to use differential calculus to locate those turning points. So these last two methods are useful, especially when we want to find exact solutions, where a graphing calculator would give you an approximation. You should be aware that the maximum or minimum does not always occur on the first derivative that's equal to 0. It is essential to also examine the values of the function at those endpoints of the interval under the consideration of the global max or min. So here are going to be the steps that we're going to follow for optimization problem solving. So step 1, we're going to draw a large clear diagram of the situation. Step 2, we're going to construct a formula with a variable to be optimized as the object. It should be written in terms of one variable, for example, x. You should write down that domain restrictions that are on x. Step 3, find the first derivative. And then find the values of x for which the derivative is 0. Those are called your critical points. For each stationary point, use a sign diagram to determine if you have a local max or min. Then, step 5 is to identify the optimal solution. Also consider endpoints where appropriate. Then you're going to write your answer in a sentence, making sure you specifically answer the question and make sure you have your appropriate units. So we will be doing an example in the next video.